In the blue guided practice, and we are going to be doing numbers 4, 5, and 6. Why not number 7? Just go ahead and take a look at number 7. It looks awful. This is what we are doing tomorrow on an early out. Lovely. This is called a complex fraction, and it's essentially yesterday and today put together. So we are going to be subtracting the two fractions on the top, adding the two fractions on the bottom, and then multiplying by the reciprocal to handle the division in between. So tomorrow we'll be kind of putting multiplying and dividing and addition and subtraction together. But for today, we are going to be doing more of these addition problems. So first we identify our operation. It is addition. And we start by trying to factor those denominators. Can we factor those? We can take a 6 out, which will leave us with 2x plus 1. And then in my second fraction, we can take a 9 out, which will leave me with 2x plus 1. So the importance of taking the GCF out is that we now have a shared factor between these two. Now for the 6 and the 9, we have to break these down a step further, because they are monomials into 2 and 3 and 3 and 3. So to find the LCD, least common denominator, we are going to take the greatest amount of each item. So starting with the monomial parts, what's the greatest amount of 2's that I have in one fraction? 1. What's the greatest amount of 3's that we have in one fraction? 2. So these two 3's override that single 3. So then 2 times 3 times 3 gives me 18 for my LCD. What's the other part of my LCD going to be? The 2x plus 1. So folks, on the homework, I expect you to state what the LCD is and also on the test. Here. So that's going to be considered part of your work, making sure you can not only find the LCD, but use it. So let's show a little less work here. What am I going to need to multiply this first fraction by to get this denominator to be equal to my least common denominator? How do I make 6 look like 18? Times 3. So times 3 over 3. What about this one? We've got 9 and we've got 2x plus 1. How do I make the 9 look like the 18? Times 2 over 2. So instead of rewriting the whole next line, I'm just getting a little lazy with my work, showing it right by the original problem. So now we distribute on the top. So 15x minus 24. And then slide the denominators together. Now when I slide, we are going to put those monomials together. 3 times 6 is 18. And then the 2x plus 1. Then for our second fraction, when we multiply 2 times x and 2 times negative 3, we get 2x minus 6. All over 18 times 2x plus 1. So now that we have a common denominator, what are we going to do with the tops of those fractions? No. No, if you pop that, you buy it. So 15x minus 24, we're going to add that to the top of this one. So that is 17x minus 30 all over that common denominator. So our final step is seeing if we can factor or simplify this any further. 17x minus 30, is there any GCF I can take out? No. 17 is prime, so can't take anything out as a GCF. So that's it, folks. That is our final answer. And if it pleases and sparkles, you can trap that top in parentheses. Questions on that one? Is it starting to make sense on how we are finding the greatest amount of each term for that LCD? Let's go ahead and I want you to see if you can determine the least common denominator for this one. I Actually, get to the creative forms of 1 as well. So least common denominator, and what are we going to multiply as the creative forms of 1 to get to the common denominator? So factoring wise, we've got difference of squares on the last one. So x plus 4 and x minus 4. And the 4s, we can break those both down into 2 and 2. So what's the greatest amount of 2's that we have in one fraction? 2. So our LCD is going to be 2 times 2 or 4. And then what about the other part of our LCD? We'll need x plus 4 and x minus 4. So x plus 4, x minus 4. Raise your hand if you had that right, the LCD. Good, good. So now, to use our creative forms of 1, this first fraction is missing the x minus 4. So I'm going to use that as my creative form of 1 over here. X minus 4. X minus 4. This one is missing x plus 4. So x plus 4, x plus 4. This one, what do we need for that last fraction? 4 over 4. So on the next line, I want you to carry out the distribution of the tops and slide in the denominators together. How did we do? I almost forgot to multiply the 8x by the 4 there, so 32x there. So from here, now that we have common denominators, we're going to add all those tops together. So like term-wise, I've got negative 5x and 3x. That's going to be negative 2x plus 32x is 30x. Then for our constants, 20 plus 12 is 32. And this is all over 4 times x minus 4, x plus 4. Does the order of the factors on the bottom really matter? No. Now, what about the top? Can we factor that? What's something we can take out of both 30 and 32? 2. 2 is going to be our GCF. So I'm just going to write this above here. So 2, 15x plus 16 all over 4 x minus 4 x plus 4. Is there anything I can cross off? So we were able to factor it, and check it out. We can take a 2 out of both of those monomial parts out in front, and that will leave me with a 2 on the bottom. So wow, my final answer will be 15x plus 16 over 2 times x minus 4, x plus 4. So folks, this is the first problem we've had where we actually could do a little bit of simplifying at the end. So this is important because it didn't mean we missed anything in the beginning. There's nothing we can simplify in this fraction, nothing we can simplify here, nothing we can simplify there. But sometimes when you add the tops of the fractions together, you create something that can be factored and possibly simplified. Maybe it's just a scuzzy little GCF, or maybe you'll be able to cancel out one of the factors with one of your denominator factors. So once you get to the end, always check to see if you can cancel by factoring. Let's go ahead and take a look at the next one. We've got x, we've got 4, we've got 4x. What is the LCD? Four x. Hooray. So you could break that up into 2 and 2, that up into 2 times x. Greatest amount of 2's you have is 2, greatest amount of x's you have is 1. There's something else we should take care of before we get too far in this problem. What is it? The negative. So always identify your operations first. This is a plus and a minus. And the minus we are immediately going to change to a plus by distributing it to both items of the top. This one I want you to try entirely on your own. I'll give you a few minutes to try this one. So think about what you're going to use for your creative forms of 1. You can just write those next to the original problem. Add your tops together and then check to see if you can factor and or cancel. What's x times x? X squared. So that was something that I saw on the last test when we were superfoiling. Make sure that you write x squared and not 2x. It's x times itself twice, so we do get x squared on the top of this middle fraction. And then negative x minus 2. And when we add those tops together, we get x squared minus x plus 10. Now, if I were you, I'd be a little unnerved by that quadratic on the top, because normally when we have a quadratic, we try to factor it. Is there any way for me to get a product of 10 and a sum of -1? And if you're like, do we have to use the quadratic formula? No, we're not solving for x. We are just trying to factor and simplify. So that's as good as our answer gets. That's our final answer. So next, we're going to go into the homework packet.